Okay, today we are graphing logarithms, and the nice thing is, once again, it utilizes how to evaluate logs. So again, reinforcing this concept. So let's see, I'm thinking of a number. Okay. Cassidy. Number 1, what did you get? Okay, good. So my question now is why? Why is log base 3 of 81 equal to 4? Hold that thought. Colin, why is log base 3 of 81 equal to 4? I love how you said that, because 3 to the 4th power equals 81. Because if you give it a swirly, that makes perfect sense. Okay? I should see little swirlies all over your paper. Okay? All right, number 2, let's see. Olivia. 1. Good. I want to know why from Janessa. Because if you do the swirly, it makes perfect sense. So when you get the swirly, what should I write down? Excellent. 5 to the 1st equals 5. Very, very good. And that makes total sense. Okay. Last one, number 3. Yasmina. You got 1. 0. Why? Because no. 7 to the 0. All right. So 7 to the power of 0 always equals 1. And that's true. Any base to a power of 0 always equals 1. Absolutely important that you understand this concept. Give it a swirly, and then that makes sense. All right, so today we are graphing in this form, log base b of x minus h plus k. So today, you should be writing this down. We are graphing in this standard form with h's and k's that we've done a lot of this semester, right? What does the h do to our graph? Always, always. It shifts it left to right. Yeah, it's a left and right shift. Shift left or right. What does the k do to our curve? Up or down? And that's kind of a nice thing. So all we have to worry about is this piece right in front, which we call the core or the base or the parent function, which is a very, very simple function. And it's also, if I flip it around, the same form as what we just did, which means I should be able to give it a swirly and find some easy values, okay? So we're going to create a small table of values and then plot a couple points and shift them like we've done all semester. So it's quite nice. All right, so let's do just a couple here. Example 1. Remember, please write example 1. Graph the function. State the domain, range, and vertical asymptote. Graph the function. State the domain, range, and vertical asymptote. I have, for my first problem here, y equals log base 4 of x minus 2 plus 3. And again, we want to find the domain, range, and vertical asymptote. But before I get there, I'm going to use 2 colors and start with just my core function. This is my core. y equals log base 4 of x. And I'm going to start just using a little xy chart. I'm going to flip this around. Log base 4 of x equals the y value that we're going to plot on our graph. And I want to find some easy x values. And this turns out to be the easiest thing. 1 is always an easy number to plug in for pretty much every function. So let's see what happens when I plug in a 1 for x. Log base 4 of 1 equals, what does log base 4 of 1 equal? 0. Why? 4 to the 0 always equals 1. Because if you give that a swirly, that makes perfect sense. Any number to a power of 0 always equals 1. This is called the log of 1. The log of 1 always equals 0. Every time. So that's a super easy point. What's another number that would be very good to use for x? Think about the warm-up we just did. What's another number I could use? Log base 4 of 4. Log base 4 of 4. What does log base 4 of 4 equal? 1. Why? Because 4 to the first power always equals itself. So we're going to use these 2 points every single time. Not necessarily 1 and 4. Always 1. And always whatever your base happens to be. Because they're always going to turn out super nice. So here our base was 4, so we use 1 and 4. Here our base is 2. What values are we going to use? 1 and 2. Every time. All right. We could also use another number, and I'm just going to do this one time. 1/4 is also an excellent choice. Log base 4 of 1/4 equals what? -1. 4 to the -1 power. Negative exponents create fractions, right? So 4 to the -1 equals 1/4. So what I have here, some easy points. 1, 0 is right here on my graph. 4, 1 is right there on my graph. And also 1/4, which is 0.25, just a little to the right of the origin, and -1. I could choose some other values like 1/16. 1/16, it would be a -2 for my output. And 1/64 would be a -3. And 1/256 would be a -4. What's happening as I'm choosing very carefully chosen fractions? Smaller and smaller fractions. What's it doing? It's getting closer and closer to what is an asymptote. So there is a vertical asymptote right here at x equals 0. On every logarithmic function, there is this asymptote that we just approach. So our graph looks like this. This is what I lovingly call the log ride. It reminds me of a log ride in an amusement park. It's the inverse of our Superman graph, our exponential graph. Exponential growth goes up. This just grows very, very slowly. It reminds me of a log ride because the first thing you do on a log ride is you get in the little log. And on every single log ride, the first thing you do is go up. Click, 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 right? Don't you do that on every single log ride? And that's what's happening here. We're just going up, 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 up. And then once you get up, then it's like the slowest, most boring ride ever, right? It's a small world after all, right? You just sort of float around and look at animated stuff. It's very boring. Save the very, very end. But still, 90% of this is super boring. So we're just going to, this is how every log function is going to look for us today. it goes up, 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 and then sort of just fizzles out. It's growing, but it's so slow, it's the boringest thing ever, okay? Now, we have graphed our core functions. We just need 2 points because every function is going to be the same. How are we going to shift those points? What does the x minus 2 do to the function? It's going to go right 2 units. What does the plus 3 do? Up 3. So I'm going to take these 2 main points and go right 2, up 1, 2, 3. Right 2, up 1, 2, 3. Now I have a question for you. This has a vertical asymptote. It had an asymptote right here at 0. And then we had to shift the graph 2 units to the right. Where is my vertical asymptote? Does it stay at 0 or does it move as well? It moves as well. It's going to shift right 2 units as well. So now it's right here at x equals 2. You must have a vertical asymptote on your graph. I need to see that asymptote. That is the most important feature, apart from the shape. So we have a vertical asymptote at x equals 2. Where did that vertical asymptote come from in our equation? The bubble right here, x minus 2. It came from the bubble. And how did we go from the bubble to x equals 2? What did we do? We went right 2, but really it's actually an equation that we're solving. It was at 0. And then to solve for x, we would have to add 2. Add 2, and that's how we get x equals 2. So every single time, our asymptote is going to come from this bubble with x. Okay? What is the domain? What is the domain of this purple function? How far to the left and how far to the right does it go? Goes to infinity, out to the right. It's going forever to the right. Where does it stop over here? At 3? Well, wait a minute. This is left of 3. So how far, like, where? 2. Yeah. So it starts at 2 and it goes forever to the right. We use a parenthesis because that means that we're getting so very, 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 very close to 2, but not actually ever going to equal 2 because it's already an asymptote. It can't also equal 2 here. So we make sure we use the parenthesis. What's the range of this graph? Negative infinity to positive infinity. Forever down and forever up. How low and how high does it go? All right. Letter B. My core function is log base 2 of x. So I'm going to set up a little xy chart. I'm going to flip it around. Log base 2 of x equals y. What numbers should I plug in for x? 2 is an excellent choice. What's another excellent choice? 1. Always use 1 and the base. 1 and whatever the base happens to be. So I'm going to plug in the 1. Log base 2 of 1. What's the log of 1? 0. Every single time. The log of 1 equals 0. Because 2 to the 0 always equals 1. What is, if I plug in a 2, log base 2 of 2? 1. Every single time. Because 2 to the first equals 2. Give it a swirly. It makes perfect sense. So I have the point 1, 0, and the point 2, 1. There is an asymptote at 0. And it looks like this log ride. How do we shift this little log ride? Left 3 and down 1. So I'm going to take these 2 points and go left 1, 2, 3 and down 1. Left 1, 2, 3, and down 1. Where is my vertical asymptote now? Where is it? -3. X equals -3. Comes from right here, inside this bubble here. So I'm going to make that asymptote first. I do need to see the asymptotes on your graphs. And again, you can't cross the asymptote. You get very, very close to it. What's the domain? -3 all the way to the right. -3 forever to the right. What's the range? -infinity to +infinity. Do you guys have any questions for me? The range is always negative to +infinity. Yes. Any other questions? What values should you choose for x? 1 and b, whatever the base is. 1 and the base. All right, ladies and gentlemen. You have